Hello, here we are continuing to talk about rational numbers. Today we're going to talk about subtracting rational numbers. We're going to dive right into this. It says you subtract a fraction or a decimal the same way you subtract an integer. So the same rules are going to apply that for any rational numbers A and B. Let's recall that rational numbers are decimals, fractions, integers, whole numbers. That for any rational numbers A and B, you are going to rewrite your subtraction problems as addition problems. Not addition problems. So A minus B becomes A plus negative B, and A minus negative B becomes A plus positive B. Okay? Just another quick little example here showing us with fractions and decimals, because sometimes we don't like to see things written algebraically. Okay, this is in algebra. People like to see things with arithmetic, which means numbers. They're showing us here that we have negative 3/5 minus 4/5. So write subtraction as adding the opposite. So stop, add the opposite. Negative 3/5 becomes, negative 3/5 minus 4/5 becomes negative 3/5 plus negative 4/5. And then they go ahead and show the signs are same. So I add, keep the sign, get negative 7/5. Then they're showing us the same exact thing. Now this time with decimals, again, still rational numbers. We have a negative 9 1/10 minus negative 7 6/10. We need to stop and add the opposite, which means we're going to rewrite our subtraction as an addition problem, and we get equivalent answers. So number one is asking us to model each subtraction expression on the number line. They want us to then find the value of the expression. Now, they've been very kind to us here because if you notice on the two number lines, they've broken down the space evenly for both of these. So we start at 0, and if it says I'm going to start at negative 1/2, negative 1/2 shows me the direction of going to the left. And so if you notice, between 0 and negative 1, this is split up into 1, 2, 3, 4, 5, 6 spaces. Because I have a denominator of 6 right here, they're splitting up all the 1s into 6s. So negative 1/2 is actually equivalent to negative 3/6. So I'm going to be moving over to negative 3/6, which is going to be located right here. Then I am going to be subtracting 5/6. So I'm going to continue moving towards the left, and I'm going to be moving 5/6. So I'm going to be 5 spaces. 1, 2, 3, 4, 5, which has me end right here at negative 1 and 2/6. Negative 1 and 2/6, which reduces down to negative 1 and 1/3. Okay? Continuing then to move in this direction. For the next one, again, we start off at 0. It's asking us to go to negative 2 1/4, which conveniently happens to be all the way at the end of the number line. When I subtract, I move to the left, but it's subtracting a negative, so I'm actually going to be turning around and going back towards the right, and I'm going to be moving 3 1/2 spaces. Bear with me here on my description. If I'm at negative 2 1/4, one whole would be right here at negative 1 1/4. Then another one whole would be at negative 1/4. And then another one whole would be at, let's see, did I go the right way? Yep, would now end me up at 3/4. Did I say that right? Okay, just want to make sure I got that right. Then I need to move another half, which is going to be, since these are split up into 4 groups of 4, between here and here I have 4 spaces. Half of those 4 spaces would be another 2 smaller spaces. So I'm going to be moving all the way to the end, and that will bring me at 1 1/4. As you can see, modeling the rational numbers on a number line is not as simple as modeling the integers. You can still use the number lines to estimate what your answers would be, but they're not always extremely efficient if you have different denominators, and especially when we start getting into larger denominators. Go ahead and give number 2 a try. I think this one will be very similar to what you will see on your practice. And I chose choice 2 on this one because, again, you're starting off at positive 1 3/4, and then when you subtract a negative, you actually turn and go to the right. Question number 3 says that carbon dioxide and nitrogen are 2 gases found in air. Both gases can be used as coolants in solid or liquid form. So which of these temperature is higher, and how much higher? Well, when I stop and look at this, I've got negative 78 and 5/10 and negative 195 and 79/100. The higher temperature sounds like the carbon dioxide to me. Because if I'm thinking of a number line, if this is 0, negative 78 is a lot closer than a negative 195 to being, it's higher, literally. It's not the fact that it's closer to 0, because if you say a number is bigger because it's closer to 0, that won't work if you are talking about positive numbers, because positive numbers, the closer they are to 0, the smaller they are. So don't give me the answer that it's closer to 0. It's because literally on this number line, it's higher. So when they say how much higher, I'm really thinking, well, I need to find the difference between these numbers. And if I need to find the difference between them, when you set up a subtraction problem, you subtract the greater number from the smaller number. And if technically, can I just say that backwards? You subtract the smaller number from the greater number. So the greater number is 78 and 5/10. I'm going to subtract the negative 195 and 79/100. You then rewrite this as an addition problem by adding the opposite. So the subtraction becomes its opposite, which is addition, and the opposite of negative 195 and 79/100 is positive 195 and 79/100. So I want you to notice that when I'm setting this up as a subtraction problem, originally I'm writing it horizontally to help with my order. Now, when I look at this problem, I see that I need to have 195 and 79/100 on the top because that one has the larger absolute value. And I have plus a negative 78 and 5/10. Because I have addition and my signs are different, technically I'm finding the difference between these numbers. And since the 195 and the 79/100 is giving me, it's a positive, that's my answer will be positive. So I go through and subtract, borrow here, 15 minus 8 is 7, 8 minus 7 is 1. I get 117 and 29/100. Hopefully I just didn't thoroughly confuse you with saying everything backwards. Go ahead and look at number 4. When you come back, that will be all complete. Okay. I knew right off the bat here when I rewrote my problem as an addition problem right here, I'm rewriting as an addition, I knew that since negative 210 has the larger absolute value, I knew my answer needed to be negative, so that's why I crossed off C and D, because both of those answers are positive. So now I had to decide, am I actually going to be adding these numbers together? Are they going to be combining forces, or would I be subtracting and finding the difference? And since they are different signs, I do take the difference. So by process of elimination, would have seen that B would have been the answer, but I went through and also subtracted just to be sure. Now question number 5 says that a roadway, a new road that connects Uniontown to Springville is 4 1/3 miles long. What is the change in distance when using the new road instead of the dirt roads? So the dirt roads are right located here, which are conveniently highlighted. And then the new road is labeled as the new road. So the change in distance is going to really be the difference between those. So I have to first find out what was the distance of the dirt roads and then subtract the new road from there. So let's go through and make sure that we're on the right path here. So I'm going to take the 2 3/8 and add the 3 5/6 together to get me what the length is of the roads. As you can see, I do not have common denominators, so I need to get a common denominator. At this point, some people might want to change their questions to improper fractions. But again, I don't like to do that because then you end up dealing with larger numbers. So I'm going to be careful. The 2 and the 3 will stay the same. The common denominator between 8 and 6 would be 24. So 8 times 3 is 24. 3 times 3 will give me 9. 6 times 4 is 24, so 5 times 4 will give me 20. I add these up, I get 29 24ths. And 2 plus 3 will give me 5. But that, for right now, I know that I'm dealing with an improper fraction. I'm just going to leave it as an improper fraction because they want me to find the difference between, or they said the change in the distance. The change in the distance would be the difference. So I'm going to have the 5 and 29 24ths. Subtract the 4 and 1/3. Now the reason that I left it as an improper fraction is when I go right to this point to convert or get common denominators. Okay, to go from 3 to 24, I would multiply by 8. So 1 times 8 would give me 8 here. The reason, again, why I'm leaving it as an improper fraction is because if I had changed the 29 24ths to 24 24ths and added one whole on to the 6, I would have had an 8 taking away from 5, which I would have then had to go through this whole process again anyways. So that's why I left it in this scenario. So I've got 21 minus 8. No, I just lied because I gave you the answer. 29 minus 8 would be 21. 24ths, and 5 minus 4 will give me 1. And then I'm going to reduce 21 24ths. They're both divisible by 3, so it'll be 1 and 7/8 would be my final answer. So on the remaining bit of notes here, we have 9 questions. I'm asking for you to answer these following 9 questions in an organized manner, which means on a separate sheet of paper. I'd like you to go ahead, no calculators, write the questions out. I want to see the work. This will let me know who's really watching the videos and taking the time to answer these questions. I will see you guys tomorrow. Have a great night.